Wouldn't it be nice if all your dumb health choices over the years could be biologically forgiven, the way society forgives everything we did in high school because our prefrontal cortex wasn't fully online? Well, good news. Your body happens to be a cellular regenerating machine. With a few caveats. Because the cells responsible for this regeneration have a few prerequisites in order to get their forgive on. Especially if we're really looking to defy the longevity odds, keeping them ready and steady for the long run. Which, as you can imagine, is a lot easier said than done. Here's the secret X factor you need to know about. Let's go. Yo, what is up? Welcome back to another week of How to Health. My name is Kevin. I run liftingbalance.com, where we take aim at all things health and longevity and do it in an odd, weird, interesting, and highly sarcastic way. Today, after a short, unplanned hiatus, we are back on the topic of stem cells. Yes, the pools of immature, non-differentiated blobs of molecular wonder, which await the signal to spur into proliferation and differentiation, and ultimately the specific cells you need at that specific time to carry out and, dare I say, optimize your biological function. Whew. Magical little buggers, aren't they? That being said, these buggers, just like many of the other systems that we've covered in depth across the many deep dives on this channel, get rusty, dysfunctional, and even unresponsive as we accumulate chronological years on this beautiful floating rock, creating a little bit of a perfect storm dynamic. And here's what I mean by that. We know with a pretty fair amount of certainty that one of the key compounding factors of aging is the accumulation of cellular damage. But not only that, in parallel, many of the pathways built to repair said damage become dysfunctional too. And if that weren't enough, the pools of stem cells strategically positioned in key areas such as the gut, brain, blood marrow, muscle, liver, and skin, to name a few, get less good at springing into action and renewing their respective tissue. Albeit, all of these tissue types renew at different rates, from periods of days, as with blood, gut, and skin cells, to, well, pretty much never, as is the case with neurons. But if you really want the inside scoop with adult neurogenesis, check out this video here. You won't be disappointed. Anyway, returning to our trifecta of dysfunction, there happens to be one common theme that always seems to be poking its organelle head up whenever things go biologically wrong. And darkness, my old friend, it seems to be the case again: mitochondrial dysfunction. A biological happening which we cover ad nauseum on this channel, especially as it pertains to being the origin for many of the molecular problems linked to the creation and proliferation of almost all disease states that we modern humans face. And once again, when you think about it, it kind of makes sense, as they are highly reactive, energy-producing organelles, not only responsible for the energy production of almost every single cell in our body, but also the origin of inflammation-inducing and cellular-damaging reactive oxygen species, a compound which becomes much more prevalent and problematic as mitochondria become weak, leaky, and damaged, which is a common byproduct of our modern, ultra-processed, ultra-sedentary, sleep-deprived ways, might I add. But back to stem cells, because I never even thought to explore if these life-enabling organelles had an impact here. And let's just say, I shouldn't have been surprised with what I found. So to set the stage for this significance, let me first give you a little backdrop on stem cell behaviors. Because, like I mentioned before, there are many different types of stem cells, with most programmed to differentiate into a handful of different yet specific cell types for the body. And you may be wondering, what exactly is differentiation? Well, at a high level, there are three main phases to expect to find stem cells in. The first being quiescence, or a state of dormancy. kind of like a cellular coma. And this is the state that many stem cells in those aforementioned stem cell pools across the body tend to stay in for the majority of the time. It is only when they are signaled they first begin to proliferate or rapidly divide, and second, begin to differentiate or turn into the specific cell that tissue needs at that time. Now, the super interesting thing about stem cells in a quiescent state is the fact that most of them do not synthesize the majority of their energy using mitochondrial oxidative phosphorylation, aka using the mitochondria and its electron transport chain to create energy, the way most cells do it. Instead, they use the much less efficient glycolysis, which was news to me, and that's why I love doing this stuff. Learning. Off the charts. But why would a cell choose to do this rather than using their energy factory of an organelle that can churn out 10 to 15x the amount of ATP per molecule of glucose? Well, the main reason likely comes down to the fact that these dormant, comatose cells don't need that much energy. And by bypassing the mitochondria energy-producing pathway, they reduce the odds of oxidative damage via reactive oxygen species, which are leaked out of the mitochondria. Alright, but wait a sec. If that's the case, then why exactly are mitochondria so important to these cells? Great question. Because as counterintuitive as cells that don't rely on mitochondria for energy, yet sneakily rely on them for proper cellular function may seem, that appears to be the case here, as mitochondria still perform critical functions in quiescent stem cells even though they do not produce the majority of their energy. This includes biosynthesis, calcium signaling, and redox regulation. And when their function gets compromised, these magical pools of biological vitality can turn into molecular paperweights pretty fast. For example, if mitochondria malfunction due to mutations, damage, or impaired dynamics, it can lead to metabolic imbalance, impairing the stem cell's ability to function, increased reactive oxygen species production, elevating the propensity for more damage, impaired redox signaling, putting at risk the stemness of the cell, which we'll talk about what that word means in just a minute, disrupted biosynthesis or inability to synthesize the compounds needed to function, calcium signaling defects, which is one of the ways stem cells get activated, so that ain't good, and impaired cellular cleanup via autophagy and mitophagy, allowing the damage to accumulate and further impair the cell, ultimately causing the stem cell to lose their stemness, or all the unique pathways, factors, and characteristics which allow stem cells to proliferate and differentiate, reduce their pool size due to an uptick in senescence and apoptosis, which shrinks their quiescent reservoir, impair their activation pathways, hindering their ability to proliferate and differentiate when the body needs it, and unfortunately increase the prevalence of a aging phenotype, which are essentially increased signs of biological aging all throughout the body. Not cool for biological school. I know. Thus, why we can now officially add stem cell stemminess and longevity to the list of mitochondria health and function dependent pathways. I mean, I shouldn't be surprised, but here I am. Now, the good news with having a lot of those systems and pathways on that mitochondrial dependent list, many of which we cover in those aforementioned deep dives, which will be linked in the show notes below, is the fact that taking action and doing things that put your mitochondria in a position to be strong, efficient, functional, and flexible can improve a lot of biological situations at once. So it is a great target when deploying interventions to improve your life. And as you know, we love talking about those lifestyle-based ones the most. And since you brought it up, Here are some of the most impactful. First, performing a mix of aerobic and strength training several days a week, with a healthy dose of zone 2, typically in the 50% to 70% max heart rate range, for 1 to 2 30-minute sessions a week, adding a session or two of high-intensity work for 10 to 20 minutes each, and resistance training 1 to 2 30-minute sessions a week. There are a lot of different ways to approach this training, and it is all dependent on where you are currently at. So take your time and ease into it. Next, there is the prioritization of real, whole, nourishing foods. You know, the ones naturally filled with vitamins, minerals, protein, fiber, phytonutrients, antioxidants, and healthy fats, while ditching the mitochondrial damaging, ultra-processed, additive-riddled, way too common alternatives. And while eating, aim to do it in a consistent 10-hour or less feeding window each day, performing a 14-hour overnight fast. If you want to know why, check out the Why I Eat Early video in the show notes. You also shouldn't be surprised that mitochondria efficiency is highly dependent on getting consistent, high-quality, circadian-aligned sleep as well, as good consistent sleep is a major modulator of mitochondrial bioenergetic dynamics. And when doing all this awesome healthy stuff, it really helps if you clean up your exposure to all that sneakily damaging stuff, with the obvious ones being habits like drinking, smoking, recreational drugs, and vaping, and the not so obvious ones being the harsh chemicals and toxins found in your home cleaning supplies, cookware, drinkware, body care items, and even clothing. So keep your head on a swivel. If you wouldn't eat it, don't put it on you. Only if you're eating healthy stuff, I guess. Lastly, we have spending more time in the stress-reducing, biologically boosting nature. This keeps circadian rhythm strong, the microbiome happy, and mitochondria vibes flowing. Oh, and good stressors such as sauna, steam room, ice plunge, and cold exposure in general are mitochondria favorites as well, for those who want to go above and beyond. And if you do this, you'll be running your best race and unironically feeling effing awesome while doing it. Experiencing something that many people never experience on this beautiful floating rock. Feeling how they are capable of feeling. In many ways, thanks to your mitochondria accomplice, vibing efficiently within each and every one of your cells. And stem cells, likely increasing their stemminess for longer. You know, now that I think of it, I don't think stemminess is an actual word. But after a powwow like this, I think it's gotta be. So get out there and get your stemminess vibe on.